At this point in the course, I wanted to go back and take another look at strings. I hate to admit this to you, but I've actually been kind of lying to you all along. There have been many different times in different segments that we've gone to that I've mentioned that strings are a scalar, a primitive data type, a simple data type. In actuality, strings are actually objects. I don't feel especially bad about lying to you because even though strings are objects, JavaScript does include some nice shortcuts for us that make it possible for us to be able to treat them as if they were very simple scalar data types. For example, we've done all this before, but let's say that I create a variable called name and I put a string into it, Victrola Firecracker. Right? Now normally that's not the way that a new object would be created. Typically if I was creating a new object I would do something like new string and then I'd have this inside parentheses. But with strings that's entirely not necessary. Instead, JavaScript lets us create strings the same way we'd create any other simple type of data with its literals and with its variables. And of course, as we've seen numerous times before, this will work just fine, and I will end up with the name, the string, Victrola Firecracker stored here inside my name variable. But some of the areas of strings that we haven't really looked at yet is, of course, those corresponding to the fact that even though we create them as if they were simple variables, simple data types, strings are actually objects. For example, let's start throwing in some document.write lines here. Right. We, of course, know that I can say name, right, and it will print out the name. Okay, but did you know we could also do this? Document.writeLine name.length, the same way we do with arrays. And it comes back and tells me 20. If you actually count through the number of characters here in Victrola Firecracker, you'll find that there are exactly 20 of them, including the space between the two names. So just like an array, the name object or names as objects have a length attribute that will tell us how many characters there actually are, what the actual length of that string is. There are still other things that we can actually do with strings as well. Besides having an attribute like length, strings also have some methods that we can use on them. For example, if I do name.bold, right, it comes back and it gives me the name actually formatted in bold, just like if I had put B or strong tags around it in the HTML. There are quite a few different methods in that vein that we can actually use for formatting strings on the fly. Okay. Oh, just thought of something else. How about this one? What if I actually created a string literal here, hello world, right? And I then put a method directly on that. How about something like big, the big method? There it is. Two interesting things there in that statement. One of them, of course, is the big method, which is another method of string objects that can be called. You can see that it formatted that text bigger, step larger, basically, than text would normally be rendered. But it's also worth noting here, notice that I didn't actually call it directly on a variable. I called it on the string literal itself. JavaScript looks at that string literal, converts it immediately into a string object, and then just simply calls the method on it that we asked for. So beside bold and big, okay, there are others that we can also use, other methods like fixed, which puts it into a fixed width font. There's methods like font color. Let's throw that one in. It's a little bit different because it actually takes an argument. Let's go back to using name again, name.fontColor. Can't remember if it's supposed to have a capital C or not. Let's try it with a little c and see what happens. All right. With font color, what I do is I actually pass it a color like I would in HTML. So if I did pound FF0000, for example, the name comes up in red. All right. So font color is another one of the possible methods that can be called. There's a font size method. There's the italics method, small method, sub, S-U-B and S-U-P, sub and sup, which are for subscript and superscript. Okay. There's a method that we can use for strings called link. The way it works, what I'll do with this one is I'll create a string literal, Google, and then I'll tell JavaScript to turn it into a link for me, and I'll tell it that I want that link to go to http://www.google.com. Right? Let me go ahead and append my break here. Right? Take a look at that in the browser, and there's my Google link, and when I click on it, sure enough, off to Google I go. So it can actually automatically take strings and turn them into links for me. So that's another neat little capability. So there are lots of those sort of HTML related type methods that can be used directly on string objects. So those can be kind of fun. It's kind of useful from time to time. I would certainly rather use the link method like I'm doing here than I would try to concatenate together all the different parts of a string that would be necessary in order to turn this into an HTML hyperlink being printed out with a document.writeLine. Okay. There are still yet other methods that can be quite handy with strings. There are some that actually manipulate the string itself. For example, there's document.writeLine to uppercase. Okay, which will, of course, as you could probably guess, take our string and make it all caps. There it is. There's also a to lowercase method that can be used. Right? Another one of the methods that really comes in handy quite often is a method called split. What I'm going to do here for the split method is I'm going to create a new variable called parts, and then I'm going to take my name variable and I'm going to call the split method on it. What I'm going to pass to the split method then is a character. The character that I'm actually passing here is a space. Basically, it's just a space I type between two quotes. Now, what the split method is actually going to do is it is going to look for whatever character I pass it here, in this case a space, and it's going to take all the different parts of the string that are separated by that character and turn them into an array. So what I'll end up with over here in my parts variable is an array where every element of the array is one of those pieces of my original string that was separated by my space, which is called a delimiter in this case. So if I call the split method and then I do document.writeLine parts element 1, for example, what I end up with is just the last name, Firecracker. So it basically looked at my original string, Victrola space Firecracker, split it on the space that was right there, made Victrola the 0th element of the new array, and made Firecracker the number 1 element of the new array. So here, with the new array that I called parts, when I asked for element 1, what I got back was just the last name. So that can be quite handy in a lot of different situations when you're having to parse or break down a string in some way. Some other methods that can be handy. There is a method called char@. So if I were to do name.char@, for example, right? With the char@ method, what you do is you pass it a index, and basically what the char@ method is going to do is treat the string as if it were an array and give you back the character that is at that index number. So if I ask for the character that's at position 0, like the 0th element of an array, I get back just the V in Victrola. If I ask for character 10, it gives me back I, which is probably the I here in Firecracker. If V is 0, then 1, 2, 3, 4, 5, 6, 7, 8 is the space, 9 is the capital F, and 10 is sure enough the lowercase I. So you can use the char@ method to go through and pick individual letters, individual characters out of a string if you happen to need to do that. Right? Some other methods that are also quite handy. There's a method called indexOf and another kind of complementary method called lastIndexOf. What the indexOf method in essence does is it searches through a string trying to find some particular character. So if I were to do a document.writeLine and I was going to say on my name variable, find the index of, that's capital O, index of, and then I tell it to find the character, let's say I, okay, so I'll give it a lowercase letter I, okay, it comes back and it tells me 1. What that 1 actually means is it's telling me that at the element position 1, it found that particular character. So it saw V at position 0, and then it found I at position 1. So that's what that 1 means. If I ask it to find for me a capital F, it tells me it found a capital F at position 9. So you can actually use this to search through a string, and you don't have to search for just single characters. If I search for the word fire, for example, it tells me that it found the the word fire starting at position 9. If I ask it to find the string for me OLA, okay, it tells me it found that particular series of characters starting at position 5. So index of can be quite handy. Another thing you can do with index of, if I go back and search for a lowercase I again, it finds it at position 1. If I actually give it a second parameter and tell it to, for example, start searching at position 6, then it tells me after position 6, the next occurrence of a lowercase letter I is at position 10. So the second parameter that I give it here actually lets me specify a starting position of where the search is going to take place. So I can use that to kind of search sequentially through a string to find all of the different occurrences of some particular substring. So that can be a good one also. Like I mentioned, there is a complementary method that goes along with index of called last index of, something like that. It works the exact same way that index of does, except that it starts at the end of the string. So here if I ask for the last index of a lowercase letter I, it tells me position 10. In this case, it actually started at the end of the string and worked its way backwards until it found the character or the string that I was looking for. Notice that even though it starts at the end of the string and works its way back, it still counts the indexes from the beginning. So the I is still the 10th character from the beginning, or the 10th position in the string. It just found it by working its way backward through the string instead of working forward through it. Okay? So that's a nice one also. Let's see, the one other thing I wanted to tell you about both index of and last index of is that if you provide a character that it cannot find, what it does is it always comes back and gives you a negative number 1. So here I've asked it to find the last index of character X, and it has come back and told me negative 1, meaning simply that it cannot find that character anywhere in this string. So sometimes knowing that a character isn't there is just as valuable as knowing that it is, or knowing that a string isn't part of a larger string can be as useful as knowing that it's not, one way or the other. So there's quite a few different things we can do with strings which come in handy. Okay? We can do all kinds of different fun little bits of string manipulation this way. Lots of nice little things that we can do. There is one other method available for strings that I didn't go over previously. This is one that I've always found to be extremely handy and use fairly frequently. It's called the Substring Method, and what it actually lets you do is extract a part of a string from a larger string. Let me just show you in a concept exactly how this is going to work. Let's say, for example, that I have a string called, let's just do name again. And let's give it the name Eddie Dean. All right. If I were to call substring, maybe from inside a document.writeLine statement, just for simplicity, name.substring, for example, what I can do here with substring is I can provide two values for it. The first value will be a starting position, the second value will be a ending position, and what they will do is the substring method will return to me all of the characters of the main string, in this case name, the string that the substring method is being called on. It'll return all the characters from that string to me that fit between those two positions. So if I say give me all the characters between character 0 and character 6, let's say 5. Okay? If I actually take a look at this in my browser, okay, it comes back and it gives me Eddie. So what's happened here was I said start at character 0, which is the E in Eddie, and give me back everything to character 5. So E is 0, 1, 2, 3, 4, and then 5 is the ending position. So everything to the left of that basically comes back. I get back Eddie. So anyway, that's kind of what the substring does, but the reason that I wanted to do this in a slightly different program was I thought that we could actually maybe make something out of it this time. Something slightly more realistic than most of our examples have been. As you can see by the title that I've set on this document up here, what I wanted to do was see if we could write a little JavaScript program that would convert between miles and kilometers. What I want to do is I actually want to prompt the user, so I'm going to create a variable to store their answer in. Let's call it ORIG for the original input. I'm going to prompt the user, and I'm going to say enter a distance in miles or kilometers, I like to call them. My intention here, and I probably should describe it better to the user, is that I want the user to do something like type in 10 miles or something like 23.1 kilometers. And then what I want to do is I want to use some of the different string functions along with substring and actually figure out what unit they originally put the distance in and then convert over to the other one. So to kind of get this started, what I want to do is figure out whether they initially entered miles or kilometers. Kilometers, let's assume that there's going to be an S on the end of it. To figure out whether miles or kilometers is there, what I might want to do is use the indexOf method that we talked about previously. So maybe what I'll do is I'll make a variable, call it isMiles, right? And then I will do an indexOf on the original statement, on the original string, so orig.indexOf, right? And I'm going to tell it what I'm searching for is the string miles. I'm going to actually do the exact same thing a second time, except this time I'm going to make a variable called isKilo, and I'm going to search for kilometers. Okay? So what I'm going to do then is one of those two, or possibly I guess both of them, are going to have a value that is not, well, one of them could have a value that's a -1, or maybe both of them will have a value that's a -1. If isMiles is -1, that means they didn't enter miles. Hopefully that means they did enter kilometers. If they entered kilometers, then isKilo will have a value in it. Otherwise, it will be -1. So hopefully it'll be one or the other, and we'll be able to tell from those variables which one it actually is. So let's see. What I might want to do next is, if they didn't enter either one of them, maybe I should go ahead and let them know that they've done something wrong. So I could say if isMiles is equal to a -1, right? Remember the equal to operator, the double equal sign, okay? I'll use the AND operator. AND is kilo. Ooh, misspelled that every way you can. And if kilo is equal to a -1, okay, then what I want to do is I want to pop up an alert where I say you must specify miles or kilometers, something like that. If isMiles is not -1 and isKilo is not -1, then I don't want to actually do anything at this stage, so I'm just going to put in an empty string there so that nothing will actually happen. So let me go ahead and just test out that part of it, right? Enter distance in miles or kilometers. Let's say I put in 10 miles, right? Nothing happens. No error message. If I put in 1 kilometers, nothing happens. So it looks like everything is working out there just fine so far. What if I just put in 65? There we go. I get an error message. You must put in miles or kilometers. So that takes us past our first little hurdle. The next thing I'll need to do then is actually figure out which one of the two they entered, and based on which one they did, do a little bit of arithmetic to convert it. So if you go over to Google and you search for miles to kilometers, what you find is that Google says that 1 mile equals 1.609344 kilometers. So basically, if they enter their number in miles and I want to change it into kilometers, I can just take the value they entered and multiply it by this. All right. But before I can do that, one other thing I'm going to have to do is I'm going to have to get rid of the miles or kilometers that's a part of the original statement. Since the original statement has that in there, it's going to make it difficult for me to do, has that string portion, the miles or kilometers in there, it's going to make it difficult for me to do arithmetic on it. So this is where substring can actually come in. So I could do something like, say, if isMiles, if it's not equal to a -1, right? So it's equal to an actual value. That must mean that miles is there. So what I could do at that point is I could pull out the actual numeric value, basically everything but the miles, and put it into a different variable. So let me make a different variable here. Let's call it distance. Right? And I'm just going to initialize it, let's say, to 0. I just don't like leaving variables uninitialized. All right? So here I'm going to say if isMiles is not -1, then that means miles must have been present in the original string. I'm going to assign to the distance variable what I get by going to the original variable and calling substring on it. With substring, what I want to do is I'm going to start at character 0, which is the very beginning of the string that the user entered. And from there, I want to cut until I get to the isMiles value, so basically up to the point where it found the word miles in the string. And just for testing purposes, for right now, let's go ahead and print out in an alert statement the value that we're getting in our distance variable and see what we end up with. Actually here, I'm again just going to cap this conditional operator off with a empty string. So let me go back to our example page, refresh. If I put in 10, I of course get my error message, and then 0 is what it's coming up with. If I put in 10 miles, I end up with just the 10 part of 10 miles. If I put in 45.6 miles, I get 45.6 back. So that leaves me with a value that I can then actually use to do my arithmetic. Now I am going to also want to take care of the situation where it might be kilometers. So here I'm going to duplicate that statement. I'm going to say if kilos equal to a -1, then take the substring of the original using the isKilo value as the stopping point for the string that I'm actually pulling out. So hopefully between those two I will always end up with some numeric value in distance, assuming that they actually entered a unit. Let's take a look. If I put in 34 kilometers, I get just 34. If I put in 34 miles, I get just 34. So it looks like that's all working just fine. This alert that I put in just to check the value of distance, I could go ahead and take back out now. It's basically served its purpose. So let's go ahead and go and see if we can get the actual arithmetic done. I'm again going to say if isMiles, if it's not equal to a -1, meaning that we actually have miles, then let's take our distance and do a little bit of arithmetic on it. And once again, I'll probably need a variable to store the new value in. Maybe I'll make a new variable called new distance. And again, I'll just initialize it to 0 so I know where it's starting. So here, if the value they entered is miles, then I'm going to say new distance equals, and what I want to do is take the original distance that I just got out of the substring and I want to multiply it, by that value I got from Google, which I thought I had copied, but I guess I copied something else after that. So let me copy it again here. There we go, something like that, right? And cap this off with a nothing string, since I'm only really acting on the positive there. Right? So I should end up with a value in new distance, which is the original miles value converted to kilometers. Okay? Same basic thing then here. If they entered is kilometers, right? Then I want the new distance to be the distance divided by that number, which ought to take the kilometers and bring it down to actual miles. So hopefully I'll end up with a good value in one of those two that is the actual converted value. All right, so let's see, now that we've gotten that far, where to go next. Maybe we should go ahead and check that out and see what we end up with in new distance. There we go, just going to alert it. Right? So let's say 10 miles, it comes back as 16.09344 kilometers, which sounds about right. If I tell it I have 45 kilometers, right, 27.9 whatever miles. Okay, let's try that one more time and see if we can verify that this works. Let's say 1 mile. Still have to do miles because that's what I'm testing for. 1.609344 kilometers is more or less what I'm getting. And if I put in that many kilometers, then I should end up with roughly 1 mile. Sure enough, 1. So it sure looks like that's converting back and forth the way that it should. About the only thing left to do then would be to actually display new distance. And to display new distance, when I do it, I'd like to actually put the new unit on the end of it, maybe a little bit of a string to make it a bit more friendly for the user. So I could do something along the lines of maybe saying, it was in my head a second ago, let's say if is miles is not equal to a -1, meaning that it was miles that they originally entered, then what I want to do is I want to pop up an alert where I'm going to show the new distance. Right? Actually, let's do it this way. Let's show their original statement. Let's follow that with a space, so it'll say something like 10 miles, and then I'll have it say 10 miles is, and then I'll append on there my new distance, followed by some unit. Now, if it was miles originally, then the unit I want to add on here is going to be kilometers. So again, I'm going to cap this off with an empty string, right? And see if that works. And let's copy this, do the exact same thing again except for kilometers. If they originally entered kilometers, then show their original string and show it the converted value with the word miles on the end of it. So let's see how that works out. So enter miles or kilometers. 1 miles. 1 miles is 1.609344 kilometers. Looks good, right? How about if I enter 9 kilometers? 9 kilometers is 5.59 whatever miles. Wow, I think that just about gets it. What if I enter a number with no unit? You must specify miles or kilometers, and that's the end of it. So it looks like we pretty much have all our bases covered, and all of this would not, of course, have been possible without some of these different string functions we talked about, like the index of method that we used to discover whether miles or kilometers was included in the original string, and of course the substring method, which let us actually separate out the part of the string that we wanted from the part of it that we were going to throw away. So with all of that, plus a little bit of the operators we've talked about before, a lot of alert statements, we were able to put together something that actually does a wee bit of work. So pretty exciting.